There's a force shaping the 21st century, invisible, yet everywhere. It writes your messages, recommends your music, predicts your next purchase, and even drives your car. It paints like Picasso, speaks every language, and now it learns like a child. This force is artificial intelligence, humanity's greatest invention, and perhaps its biggest gamble. But what really is intelligence? And what does it mean when a machine claims to have it? Today, we'll go on a journey, from the birth of AI in 1956 to how it actually learns, thinks, dreams, and creates. By the end of this video, you'll understand not just what AI is, but what it's becoming. The story of AI begins long before computers. Philosophers like Aristotle and Descartes asked if reasoning could be reduced to logic, but it wasn't until the 20th century that one man made that question practical: Alan Turing. In 1950, Turing published Computing Machinery and Intelligence. He proposed the now famous Turing test. If a machine could hold a conversation indistinguishable from a human, it could be considered intelligent. 6 years later, at the Dartmouth Conference, a small group of scientists, John McCarthy, Marvin Minsky, Herbert Simon, and others, gave birth to a new field: artificial intelligence. They believed every aspect of learning could be described mathematically. Early computers like ELIZA, Shaky the Robot, and Deep Blue gave glimpses of that dream, but progress was slow. Computers lacked data, speed, and memory. AI entered what scientists call the AI winter, decades where funding dried up and progress stalled. Still, a spark remained. And with the rise of data, GPUs, and the internet, that spark ignited a revolution. Before we understand artificial intelligence, we must understand intelligence itself. In humans, intelligence is the ability to perceive, reason, learn, and adapt. It's pattern recognition combined with creativity, seeing connections where others don't. Machines mimic that through algorithms, structured instructions that tell them how to learn from data. But here's the key difference. Humans generalize from small experiences. Machines generalize from massive amounts of data. For AI, intelligence isn't awareness, it's optimization. It's the ability to find patterns, minimize errors, and make predictions. It's not consciousness, yet it can simulate understanding remarkably well. That's the philosophical question at the heart of AI. If something behaves intelligently, does it matter whether it truly understands? I learned by example, through a process called machine learning. Imagine you show a computer 1,000,000 images of cats and dogs. It analyzes patterns in pixels, shapes, edges, colors, and adjusts its internal parameters until it can tell them apart. This process of tuning parameters is powered by mathematics, specifically gradient descent and backpropagation. The system compares its prediction to the correct answer, measures the error, and adjusts. Over millions of cycles, the model learns. There are three main types of learning: supervised learning, trained on labeled data, like this is a cat, this is a dog. Unsupervised learning finds patterns in unlabeled data, clustering by similarity. Reinforcement learning learns by trial and error, just like humans learning from feedback. The AI doesn't know what a cat is, but it knows what distinguishes one from a dog. This is the core of AI, not memorization, but pattern generalization. It's not thinking, it's predicting. In the 1980s, scientists rediscovered an old idea: artificial neural networks, systems inspired by how neurons fire in the brain. Each neuron receives inputs, applies weights, adds bias, and produces an output. Stack millions of these neurons into layers, and you get deep learning, the technology behind modern AI. Deep learning thrives on data. The more examples you feed it, the better it becomes. That's why today's AIs, like GPT, DALL.E, and Gemini, are trained on hundreds of billions of data points. The explosion of GPU computing allowed these models to scale. A single NVIDIA H100 GPU can process trillions of operations per second, powering everything from language models to self-driving cars. In essence, neural networks are digital brains, not biological, but functional analogs that learn through connection and weight adjustment. AI isn't one technology, it's a constellation of fields. Let's explore its major branches: machine learning, the foundation, algorithms that learn from data; deep learning, neural networks with multiple layers for complex tasks. Natural language processing, enabling AI to understand and generate human language. Computer vision, teaching machines to interpret the visual world. Expert systems, rule-based logic systems that dominated the early AI era. Robotics, giving AI a body, perception, motion, and manipulation. Reinforcement learning, self-improving systems through feedback. Generative AI, models that create text, music, code, video, and even art. From your smartphone's face unlock to complex systems predicting protein structures, every AI you use belongs to one or more of these branches. AI isn't the future, it's the present. It's embedded into almost every digital experience. When Netflix recommends your next show, that's AI. When your phone translates a conversation in real time, that's AI. When a Tesla steers itself on a highway, that's AI. In healthcare, AI analyzes X-rays faster than radiologists. In finance, it detects fraud and manages portfolios. In education, it creates personalized learning paths for every student. In entertainment, it powers virtual influencers and AI composers. But there's a paradox. The better AI gets, the more invisible it becomes. The ultimate form of intelligence may be the one you don't even notice. With power comes responsibility, and AI holds immense power. AI can amplify bias hidden in data. Facial recognition can misidentify people of color. Recommendation algorithms can trap users in echo chambers. Then there's privacy. AI systems consume enormous personal data, what you watch, read, say, and even feel. Ethicists ask, should an AI that writes music own the copyright? If a self-driving car causes an accident, who's liable? And how do we ensure AI doesn't become a weapon of misinformation? Governments worldwide are now drafting AI regulation frameworks, from the EU's AI Act to India's upcoming AI governance model. The goal isn't to slow AI, it's to align it with human values. Today's AIs are specialists, great at narrow tasks but clueless outside their domain. That's narrow AI. But researchers dream of AGI, artificial general intelligence, a system that can reason, plan, and learn across all domains like a human. Projects like DeepMind's Gato and OpenAI's GPT-5 are early glimpses, multimodal systems that combine text, vision, audio, and reasoning. A GI could design drugs, build spacecraft, or even write better AIS. But it also raises existential questions. If a machine can self-improve, what stops it from surpassing us? Would it serve us or outgrow us? Philosophers call this the alignment problem, ensuring that superintelligent systems remain aligned with human ethics, not their own logic. The next frontier is quantum AI. Quantum computers process information using qubits, particles that can exist in multiple states at once, thanks to superposition and entanglement. When combined with AI, they could analyze datasets unimaginably faster than classical computers. Imagine training GPT-like models in minutes instead of weeks, or simulating entire molecular interactions for new drugs. Companies like Google Quantum AI, IBM, and Rigetti are racing to merge quantum physics with artificial intelligence. It's a fusion of two revolutions, one born in silicon, the other in the subatomic world. This could usher in the era of exponential intelligence, where learning systems evolve at speeds beyond human comprehension. Can a machine be conscious? Does intelligence require emotion? Some scientists argue consciousness is a product of information processing, meaning it could emerge in machines once they reach enough complexity. Others say it's something uniquely biological, born from chemistry, not code. But perhaps the truth lies in between. AI doesn't need to feel emotions to simulate empathy, and if simulation becomes indistinguishable from reality, what's the difference? The line between artificial and biological intelligence is blurring. We may soon coexist with entities that think, learn, and create, but don't breathe. AI isn't here to replace humanity, it's here to amplify it. AI doctors can save lives. AI teachers can educate billions. AI artists can inspire creativity beyond imagination. But it's up to us to decide how it's used, for progress or for profit. The question is not, will AI take over? The question is, will we use AI to build a better world? We explored where AI began, how it learns, the science behind neural networks, its real-world impact, ethical dilemmas, and future potential. AI is not a single invention, it's an evolving ecosystem built from human curiosity, mathematics, and ambition. It reflects the best and worst of us, magnified. If you believe the future belongs to those who understand it, subscribe to our channel. Because the more we learn about intelligence, artificial or human, the closer we get to unlocking the next great leap in evolution. This is FutureGen Learning, decoding the technologies that will shape tomorrow.